Hello, hello, hello. Yeah. So unfortunately, I was unsure about it because there was an internet issue. So I ended that stream, and we will continue here. Okay. The same topic only, just the network issue. Okay. Let everyone join us. 2 to 3 minutes I'll wait. Okay. It also weather is also not good. So that can be one reason for the fluctuation of the internet. Okay. So anyone can attend this lecture. Yeah? This lecture is actually about the directions. First, we'll discuss about the importance, significance. Then we will discuss about the system, the conventional system of directions, and then the what is the real possibility or what is actually uh, essence of directions. Because what you say north, south, east with the four standard, and then northeast, southeast, and all, whatever. Uh, Total eight. So four are standard, north, south, east, west, and all other are just the combinations, different combinations. So actually, the word north, the word south, the word east, word west, these four words doesn't hold any significance. Honest one, okay? Then why we just appreciate this particular system or this particular directional analysis? So that we'll discuss. Okay, but what's the real? How can we explain the system? Because now just saying that the this direction is north, this direction is south, this direction is east, this direction is west is itself hollow statement, because we can't tell a direction directly, because direction, whatever direction you are saying, it's a vector also. So vector needs direction also. So for direction you need something that's called reference point. So we will have a discussion on it, and then we will make a conclusion that what actually it is. Okay, because it's a misconception that the direction which is upward is north, which is south, which is downward is south, then which is in your left is your west, and right is east. These are the vague concepts, because we can't explain this north, south, east, west in this way. We can explain it, but we need something that's called frame of reference. That's here more specifically not frame of reference, but the reference point. Okay, the point of reference will play a vital role here. So you can't say that the direction, the arrow which is showing upward direction is north or the downward is south. That's not actually what the direction is. Okay, so I'll show you that the direction which you are saying north or which you are saying south, not you are saying, but the most of the people's just understand, or the our even the astrology. Okay, or what you say vastu. Okay, that is also based on the movement of planets and the north, south, east, west. That is also vague, because you see, when the direction is not definite, it's changing with the changing of point of reference. Then how can you say this direction is north, this is south? Even if you are defining north in this way, that uh, upward direction is north, if you are defining the vague way also, but you can't say that this is north, this is south. So I'll also show you that the direction which you are saying north, the direction, the arrow, that arrow that is showing you north will show sometimes south also and other directions also. So how can you say it's a north or it's a south? that we'll discuss in today's lecture. So that's the intro of today's lecture, and I'll show you the screen also, sharing with you the screen in just 1 to 2 minutes more. Okay, so let everyone join us. Okay, and I hope you enjoyed the yesterday's session. Okay, so if you have to see, I'm giving you the warning also that if you are ready to just accept or just ready to listen the brutal truth, then only sit in my lecture. Otherwise, please leave, because I'll not say something that everybody says. If that's correct, I'll say. But if I found any flaw in it, then I'll not. Okay, I'll not just say that this everyone is saying this is not, this is south, this is east, this is west, and this is a perfect concept. I'll not say like this. Okay, so everything, nothing is absolute, as I discussed with you in the last session also, and nothing is even the equal. Most, some things are equal, or what you say, exact, but maximum things are approximate. Okay, so I'll use the tools of physics also, and also the mathematics to explain you the directions. Okay, so let me now share with you the screen in just 30 seconds. Okay, just look. Now it's fine, I think. Yeah, so let's begin. So first of all, what's the significance of direction? Okay, see, whenever you are defining any scalar quantity, you are defining mass, you are defining time, you are defining speed. Okay, you are defining, I would say, what, some other temperature you are defining. Okay, you are defining density. Okay, so any scalar, you are defining flux. Okay, or you are defining just magnification. Okay, or whatever scalar quantities if you are defining, you don't need, or I would say you are not in the state of compulsion that you need directions to explain, because for scalar quantity, first I'll make you clear with the scalar and vector, because it's something which maximum people make a blunder in understanding, in explaining this or understanding the scalar and vector. Okay, what's a scalar, what's vector? Okay, and I'll not cover tensor. Okay, because you will get confused, because tensor is something which is quite different from it. Okay, it's an entity, and that's that will take 2 to 3 lectures also. Okay, so I'll only discuss with you scalar and vectors to just give you the info about the direction. Okay, yeah, so just look at this. What is scalar? So any physical quantity, okay, any physical quantity that has magnitude, okay, that can have direction, but most importantly, that quantity is disobeying, or you say is not following the vector law of addition. Okay, it is following its own mathematical, that is algebraic law of addition. Okay, so it is following the rules of algebra. Okay, it is following the rules of algebra. So it has magnitude. So I'm writing by m. So yeah, magnitude is really the very essential component. Okay, we say necessary and the sufficient. Okay, so magnitude, to have a magnitude for a physical quantity, if you are saying it is scalar, it must have a magnitude. That's a compulsion. Whatever it will be, magnitude can be any value, but it must be there. Okay, so magnitude is a compulsion. Direction, it can have the direction, it may not have the direction also. As you say, mass is directionless, but the quantity that is current, it's a scalar quantity, but it has a direction. So direction is not compulsory, but also not discarded while explaining the scalar quantity. A physical quantity can have the direction, and if it has a direction, then we have to check the third condition, that whether it is following the algebraic law or it following the vector law. If it is following the algebraic law, then we will say that it's scalar. If it is following the vector law, then we will say it's a vector quantity. Okay, fine. So direction possible. And talking about the algebraic law that I'm writing by A dot L. Okay, algebraic law, it will surely, okay. It's a scalar. Okay, algebraic law means simple addition subtraction that you know. Like if I'm saying mass is a scalar quantity, suppose. Okay, so what does it mean? 2 kg plus 2 kg is 4 kg. That's the simple algebraic law. Or if I'm saying that, suppose, uh, what, you take another quantity like speed. Okay, or you take distance. How can we forget distance? The distance, if you take distance like 15 meter plus 30 minutes, 30 meter, then it will be 45 meter, right? So that's there your, so algebraic law, it will obey. But talking about the vector law, surely it will not, because we can make a, you can say, we can make a discussion on scalar quantities without direction. Okay, if it is not having direction, we'll not say, we'll not discard that it is not scalar. It can be scalar. But if it is obeying the vector law, then surely it will not be scalar, because obeying vector law is clearly giving you the direction, or clearly giving you the indication that is not a scalar, it's actually a vector. Okay, so that's the concept. Okay, so for this, everything on the board. So for a scalar, magnitude is compulsory. For a vector, also magnitude is compulsory. For a scalar, direction is optional. If it has direction, we have to check the third condition to just say whether it is scalar quantity or vector quantity. Okay. So the third one, that is your, this law, vector law or algebraic law, that we have to check. But for the direction, for a vector, direction is compulsory. For the scalar, direction is optional. It can have the direction, it can't have the direction. Then talking about the third one. Okay, if any scalar has a direction, then we have to check the third one. Okay, if it is lacking in this particular, that the direction is not there, then we will surely say it is a scalar. But if direction is there, if direction is there, then we have to check the third condition. That's the, whether it is following the algebraic law or vector law. If it is following the algebraic law, then it will be scalar. If it is following the vector law, then it will be vector. That's it. Okay. So that about the your scalar and vector. Now we will discuss about the direction. What's the significance of direction? Without direction, actually, you can't do anything in the field uh, of mathematics mainly, and in the field of not algebra, but specifically if I say in the field of your vector, in the field of, if I see the nature, if someone is saying you that just go 30 meter in the north direction, then go 20 meter in the east direction, this, so that person is actually giving you the point of reference, That person will not say directly that this is your point of reference, but you have to assume that the point from where, suppose from home, you are given the instruction that you have to go 30 meters to this direction, then this. So that home is your point of reference. You have to think the direction with respect to that home. Okay, whether it is north, south, east, west, whatever you are saying, you have to think with respect to that. Okay, fine. So just have a look on it. It happened. So directions. Even the directions are also incomplete without the reference point. Okay, if you are not given the reference point, then saying any direction is also meaningless. So we will come to the main point, that what about the discussions of the four major standard direction that we say north, south, east, west. Who gave this name, north, south, east, west? First of all, it's not the one by one people. Okay, no one has given the north, south, east, west. It's just our explanation. It's just our own explanation of it. Okay, so see. Okay, what you're saying north, south, east, west. Okay, what's actually it is, itself the words north, south, east, west are not having any meaning. Okay, they are meaningless actually. The word north, if you say in Hindi, you translate to Hindi, that doesn't say that it has a meaning. But actually speaking, no definite meaning is there. Okay, if I'm saying speed, if I'm saying velocity, it has a definite meaning. But the word north, south, east, west, these are meaningless. Okay. So why we named it? What's the, see, if someone gave the name north, south, east, west, then what's the reference? So maximum people say it's on the basis of Earth's rotation. Earth's rotation. Okay. But I'm asking you that if you are saying Earth's rotation, then also you are saying the Earth is rotating in this particular direction. You must have assumed any point of reference while explaining that Earth's rotation, and then explaining the directional north, south, east, west, respectively, right? But when you are explaining the Earth's rotation, okay, when you are explaining the Earth's rotation, even there also you need a reference point to say that it is rotating in this particular direction. Okay, and then you are seeing that the also there is one concept that we say uh, on the basis of the fluctuation of magnet. Yeah, uh, Earth's magnetism, that's the concept also. But all these concepts are not enough to explain the essence of north, south, east, west. The essence of these words, I'm not taking the direction, that if you are saying this is north, okay, you are saying this is north, okay, this is north. If I draw a coordinate system, you will understand that what you say. Suppose this is there, this one, okay, let's make it a straight. We are saying this is north, this is south, this is west, and this is east, right? But when this direction is called north, actually I will say it is an upward direction. Okay, it is vertically upward, it is vertically downward, the south is vertically downward, and this is in actually this east is, I can say, horizontally, horizontally, or you can say simply it's in right direction, this is in left direction. But with respect to what? With respect to what? this point. This point. If I just remove this point and I'm explaining the whole directional analysis, I'm explaining north, south, east, west without giving the reference of this particular direction, this particular point, which is the origin, which is not 0 comma 0 comma 0, but it's, or in 2D system 0 comma 0, it's not 0 comma 0, it's origin. Okay, it's the origin. So if I'm not giving the reference point and I'm just explaining north, south, east, west, then it is meaningless. Because if I just change the your point, this point, okay, if you're saying, just saying that this is north, this is south, this is east, this is west, okay, and I'm just changing the point of reference, the whole thing's will alter. See, if I'm making this point, this particular, which I just denoted in the rectangular box, okay, if I'm making this as a point of reference, okay, so according to you, when you are not giving any explanation, you are just saying this is a north, this is south, this is east, this is west, this particular point, this particular one, it is giving the indication that this direction is your north, south. See, I am also using these vague words because your mind is trained in this way. If I'll say that vertically upward, vertically upward, it will make it confusion. Just try to understand. So according to the, or you can say with respect to this sorry, this particular reference point, this direction is so called north, this is so called south, this is so called west, and this is so called east. But I'm just changing the point of reference, POR. If I'm changing the point of reference, now this particular direction which you are seeing now, north, sorry, is not now actually the north, because now this particular is the point of reference. So this is actually the point of reference, and this is actually now acting as the origin, you can say, okay, because it's the point of reference. Or if you are confused, then you can say directly point of reference, okay. So if I'm changing the point of reference from this particular point to this particular point, now what happened, this direction is north, this one is south, up to infinity. So now what happened, what you were saying the north as this particular region, okay, this particular region is called north, which I am now, okay, it's now see here, next page, this one, this one you are calling north when this is the point of reference, okay, like this is the point. But now I change the point of reference to this one, suppose, okay. So now what happened, and this is south, okay, with respect to this. So now the portion above this line is now the north. It is covering little portion of your previous frame of reference, okay, previous reference point, sorry. But what happened to this region, this is no longer north, this is no longer north, because now the point of reference is this. So if I am making this as point of reference, so the whatever points that are located below this on this particular axis, or the direction, actually this direction, and this is actually representing the magnitude of this particular vector. Now this became south, just changing to the another one. Suppose I said this particular point, whatever it is in the 2D system, this particular point will be our point of reference. I'll explain this whole the concept of north, south, east, west with respect to this. If I'm saying this point is acting as a point of reference, then what happened? This particular direction, if I compare with your old system, then suppose I'm drawing a line parallel to it. So this particular region, which is lying in the southern region, now became, with respect to this point of reference, now it became the northern region. Northern region. Again, this particular southern region also changed. Yeah. So what happened when I changed the point of reference? Actually, okay. Then the whole concept of north, south, east, west is not applicable. But then a person who knows about the point of reference and all will say or will explain this concept of north, south, east, west. First, that person will give you the point of reference. But I am explaining the north, south, east, west with respect to me. If I am standing, okay, and I am explaining the north, south, east, west, then I will say that with respect to me, this direction is north, this direction is south, this direction is east, and this direction is west. But again, I'll say, I'll make the knowledge seeker convinced that these words north, south, east, west is not holding its own essence. These are just words, okay, and these are just used to explain direction. Itself, these words are not holding any significance. The thing that is holding the main role or the main significance is the point of reference. The time when I change the point of reference, everything changes. The concept of north, south, east, west changes. The concept of direction, or if even this one, the more extension like north, east, and northwest, whatever, four more directions, or even this particular region, if I'm explaining the term of what you say quadrant, okay, this is first quadrant, this is second, this is third, this is fourth, okay. So even in the first quadrant only, the infinite directions are possible. This direction is your north, okay, and this one is your, suppose, whatever, I don't know what happens in camera, let's go like this, whatever, east or west, whatever camera it is receiving. So even if I look at this north, southern region, and I look at this particular so-called east, there are infinite directions possible. How? Just look at this. Once you know the angles with the axes, you will surely give the infinite. Here, I am able to draw 3, 4 because for the clarity of diagram. Otherwise, infinite directions are possible. And all these directions, the concept of north, south, east, west is not incorrect until and unless you give the point of reference. But if you are explaining it in just saying north, south, east, west, not giving the idea of point of reference, then this concept is vague. Okay, explaining direction without a point of reference is meaningless, because then what are you giving the weight to this word direction? Direction itself means that it needs a point of reference to explain. Otherwise, if you are saying you are explaining the directions, you are explaining the vector without giving the point of reference, without giving the point from which these all concept you have devised, then you are even treating it as a scalar. You are not even treating it as a vector. But for explaining the direction, if you're explaining the direction, you don't need the concept of actually the scalar and vector. Direction is itself a different concept. Okay, if someone just distinguishes the scalar and vector on the basis of direction, it means direction is not the entity that came after the or you say after the explanation of scalar or vector. Direction is itself holding its significance, but to explain any direction, to give an info about any direction, you need point of reference. That's my point. Okay. So changing the point of reference changes the whole concept. So whenever if you explain the north, south, east, west, first of all, give an info that these words itself is not holding any significance, as the word distance, displacement, because these words are holding the significance on its own. Distance has its own meaning, own existence, displacement, speed, velocity, all are holding its own significance. But the word north, south, east, west is not holding any significance. The only thing, this is our helping hand to explain the direction. Because you see, if you will not use any conventional system, actually this is a conventional system. Most of the people disagree with this. This is unconventional system. This is not a real science. Even if you just study the electricity magnetism, you say that the direction of current, that is also conventional. If I want to assume this direction, see, this is just a name. See, when the name is holding any significance, then I can't alter it. It will be the blunder. But when the name is itself is not holding any significance, if I want to say this direction as south, I can see. If I want to say this direction as north, I can see. If I want to say this direction as east, I can see. If I want to say this direction as west, I can see. Because the words are not holding any significance or any uh, essence. So this particular coordinate system is also okay. Until and unless I explain that this point is for my discussion, this point is working as a point of reference. Okay, then this is okay. But everything what I explain is true 100%. But the convention is also something that holds meaning. Convention, according to the convention, the direction which is vertically upward is north. But according to the convention, the direction which is vertically downward is south. But this convention itself needed a point of reference to explain that this point is acting as a point of reference, and now I am explaining, it's my concept, it's my way of explanation that I am explaining that this, according to this, in accordance with this point of reference, this particular direction, the direction which is vertically upward is north, and the direction which is vertically downward is south, and east and west respectively. Okay, so that's the actual meaning of north, south, east, west. Okay, so that you have to understanding while explaining the direction, while just looking at the directions. Okay, let's discuss something more on it. So why we accepted then that system north, south, east, west? Because if you will say to someone that no, this direction, you will plot a coordinate system and you say that the this upward direction is south, then more than 99% people will say that you are stupid. Why we accepted that system? Why we accepted that this is north, this is south, this is east, this is west? Earth's rotation, Earth's magnetism. Okay, so everything is measured, but not exact, but approximate. So we accepted that system because it's actually based on Earth's rotation. You say sun rises in the east and sets in the west. Now, if I change the whole system, if I'll frame my own concept, that yes, I can, it's my, and it's actually the freedom of an individual to say this direction is south, this direction, because if these words are not holding any significance, they can be altered. Then your sun will rise in the north and sets in the west, the south. Yeah. So if you change the concept, everything changes. So this system, north, south, east, west, is not the real science, is not the real system, it's the conventional system. It's the conventional system that you have to take care of. Okay. So that's it for the directional concept. That was our today's lecture agenda also. But I'm thinking that we should discuss something more on it or something different also. So just have a discussion of zero dimensional system. I discussed this particular concept zero dimensional in the special theory of relativity. Okay, but there I explained you the zero dimensional system in very detailed way. But here we will just uh, summarize it and we'll just get a basic idea of zero dimensional system. Because if I'm saying any point as a point of reference, then point is itself a zero dimension. Okay, so zero dimension in single line that I can see is not something that you can visualize. Okay, the actually the human mind, the human brain is unable to visualize something that has no dimension, that has no length, no breadth, no height. So there are several ways to explain zero dimension system. First, you can say it as a point, as definition wise. You can make the transformations. You can use 1D system, 2D system, 3D system, 4D system to explain the zero dimensional system. How? Just have a look on it. Because in that lecture also I discussed with you the zero dimension, one dimension, two dimensional. But the transformation, how can we get zero dimensional from 4D, from 3D, okay, 2D. This uh, is still left. So I'll discuss with you that concept. Okay, so let's discuss it. 0D. Okay. So first of all, I'll explain you with the help of one-dimensional system. So let's take in one-dimensional system. Suppose this coordinate, which conventionally we are saying x. And one more 1D system we are just taking. You take y. Okay. This is also 1D system. Different one, but 1D. Now how you will explain zero dimensional system? You will explain the zero dimensional system as 1D minus 1D. Okay. So here you will be end up with a contradiction. So I'm showing you with the contradiction. You are actually subtracting these two vectors. This one, wait, this one and this one. You are not making the vector addition but the vector subtraction. So if this is x and this is y, and I'm doing x minus y. So actually I can do it this way, that I can take the this coordinate this as this, I'm defining this particular as y. This will be minus y. Okay. Then you have to make the vector addition. Okay. So just shift this vector here. What's the miracle you're seeing here? This. You are actually, when you are adding, you're subtracting 1D from 1D. You are ending with the direction, this direction. And it has its own length. It is not dimensionless, not having the zero length. Then, how can we explain it? So just look at it. To explain it, actually, zero dimension is a very, I can say, complex concept. Okay? Zero dimension is not that easy because when I explained with you the two dimensional. Okay, so 1D plus 1D. We take a x coordinate, we take a y coordinate, just adding it. How we get from three-dimensional system? Well, how to get four-dimensional from three-dimensional? Just adding one coordinate system. How to get three-dimensional system from four-dimensional system? Removing that time coordinate, you will be left with the 3D system. But the 2D system is itself a tough concept. So how can we handle this? Actually, explain zero dimension, zero length. There are several assumptions that you have to take. First of all, considering it x coordinate as a line will not work because line has infinite length, and we know what that if I am taking an infinite length. See, first of all, by this way we can't explain. Okay, this way is not the way to explain zero dimension. This I did to show you that what happens. Okay? This is not the correct way. Okay? But what's the correct way? First of all, you have to take the same type of coordinate, whether you are taking x, y, or the same direction you are taking. And you have to make that direction definite. You have to make the length of that vector definite. That should have a definite magnitude, not infinite. Because if you will do like that, suppose you are taking this direction, you are taking this direction, okay, and you are saying that since it's a line, because we will consider the whole coordinate system. If I'm saying this one, so this is just one part. It has the minus x part also, and this whole is making it as x coordinate. Okay, so we are just considering the one part. So we are considering this, okay, because that became the ray. You know, this particular wait, this sign is of ray. This is of line. So we actually need what? We actually need line. So if we are considering the x here, suppose x here as line, one dimensional system, then what's the length of x? Infinite. What's the length of this one? Infinite. And you are explaining the zero dimensional system. What you will do? You will subtract this 1D from this 1D. What you are doing? You are doing infinity minus infinity. What is infinity minus infinity? Infinity minus infinity is not defined. It is an indeterminate form. I discussed with you in the last session. So when it is an indeterminate form, when infinity minus infinity is an indeterminate form, then how can length be zero? Because zero is a definite quantity. Okay, zero dimension is dimensionless, means the dimension is zero. The length also is zero, length is also zero, breadth is also zero, and height is also zero. It's zero. Zero is a definite quantity, but infinity minus infinity is not a definite quantity. So to explain the zero dimensional system, what you need? You need a line segment, or you need a special type of line. Line segment is a special type of line which is or which has a fixed magnitude. Line segment is a special type of line which has a specific definite magnitude. Okay, so you have to consider a special type of line, that is a line segment that is having the definite length. Then you can explain the zero dimension from the other coordinate system. Okay. So actually this infinity minus infinity, wait, Oh, it's not same. So actually infinity minus infinity is undefined and is not equal to 0. Okay, that's it. So now we need a line segment. So to define, we need a line segment. Suppose I am drawing a line segment of definite length, say A. Definite length. I'm not saying A has a 5 or 5 units, 3 units. This time I'm saying A. This is A. And then, as I said, we have to make several assumptions. So the second one dimensional system that you are taking, you have to take up the same length. What is it? Same length. If it is exceeding this, remove, ignore it. Good. Okay. So in this way. Now you have two one dimensional system that is having the definite length. That is A, one dimension, one dimension. Now to get the zero dimension, what you have to do? You have to use the same concept, 1D minus 1D. And now you are left with the length of, or actually the A minus A. And now you are left with the zero, exact zero. So this is actually called the explanation of zero dimension by considering, by assuming that the line segment has a special type of line with the definite length. Then we are assuming also what? We are assuming also the, you can say, length of one dimensional system, and that length should be same. We are considering two different line one dimensional system, but their length are same. We have to assume this, because if you will just make an guess that suppose you are taking one as A, other as B, you'll be left with a little length. Then you can't explain it. The zero dimensional system. To explain zero dimension, see, absolutely, if you are explaining the zero dimension, that's okay. But if you are explaining with transformation using the one dimension system or other one, you need to have the assumptions. You need to have the assumptions. You have to actually make special assumptions, and the quite approximate result you will be getting, and then you can left with the this zero. Okay, that's zero. Now that's very complex concept. Zero dimension is not that easy concept. Again, we can explain it using two-dimensional system also. Let's take a two-dimensional system. Okay, so the same work you have to do. Then you have to break. You have to explain the two in the terms of two-dimensional, 2D minus 2D. Then that both two-dimensional systems should be identical. The length should be same in it. Then you have to explain in terms of x and y. Okay, differently. That you have to consider the length, some length of x, okay, then some length of y. Suppose a and b. Then the other coordinate system should also have the same length a and b. Then you will make the deduction. Then from the x also you will deduct a from a. You will be left with 0. Then you will do the same from the y. You will be left with b minus b. That's 0. Okay, so in this way you can left with zero dimensional system from 2D, 2D minus 2D. From 3D system also you can follow the same procedure. How? You can assume the length of the x coordinate, suppose as a, which is a special type. That's a line segment. We have devised it in terms of line segment. The which one? Y. Y is system. Y coordinate. That's line segment of length, definite length b. This a, b, c, these whatever I am defining, these are of definite length, these are not infinite. So the x coordinate of a, then y of b, then z of c, then you will make the deduction plus, then you will just make a what I discussed with you in last class on the concept what yeah, why the 2.5 dimension 1.75 is not possible, that we did the photocopy, that only. No, that no, that's different one, or the same one. Okay. Yeah, the same one, I think. Same one. That was also based on that concept only. You have to make the infinity by 2, then you are left with the same one. Even I discussed with the origin in one dimension, that is more explicitly that one. That one is also there, but more explicitly if I say uh, that zero dimension, one dimensional definition of origin in one dimension, you have to make the photocopy. Infinite origins are possible. That's concept. You have to make here also the photocopy. If you are defining a one 3D system of A, B, C length of X, Y, Z respectively, then that's identical system, identical three dimensional system you need. And then you will make the deduction from X, you will be left with A minus A0, Y, B minus B0, Z, C minus C0, and then you can proceed. From 4 dimensional A, B, C, and time coordinate, you can take the length T, then A minus A, B minus B, C minus C, and T minus C. Also, you have to make the photocopy of, you have to make, you need a identical system, identical 4 dimensional system there to explain. Then you can explain 4D minus 4D to 0. That's the concept of also the 0 dimensional system. Along with the explanation of directions, I explained you the 0 dimensional system. So that's it for the today's session. So that's all for today, and see you soon in the next session. Thank you so much for joining, and bye bye. Take care. I'm ending this session, and I hope you enjoyed the concept of it. For any collaboration, you can email me at my email ID as I discussed with you. That is shivansatan15@gmail.com. So you can mail me there, and then we can plan the demo session, and then we can introduce you. Yeah. Okay. Any subject, because the channel itself is knowledge ocean. So knowledge means, knowledge is not something which I can just segregate it to physics, chemistry, math, any other subject. It is uh, endless encyclopedia. Thank you. I'm ending in one, two.